Hello, welcome to my first video on Research MD. A disclaimer, I am not a doctor yet. I am a third-year medical student in the United States. So the purpose of Research MD is to explain peer-reviewed articles on interesting topics that can benefit viewers like you. And I wanted to explain, when you get like a science paper, it's like, oh, I did this study, we randomized a couple people and gave them this and then a placebo. I want to explain that in an easy and understandable way. I want to empower viewers like you to better understand the process from, doing research to that research causing the doctor to make, hey, this research recommended that you take this medicine. So I just want people to be empowered to understand like how that happens, and I want viewers like you to be interested in the reading scientific literature and not be intimidated by it. I mean, I myself, initially when I started medical school, I was really intimidated by it, and I can just only imagine how some people who are not in the medical field might feel when they see these kind of papers. And maybe if they find an interesting article on a topic that pertains to them in whatever way, they can share that scientific article to their doctors and encourage a really thought-provoking and evidence-based conversation. So my goals on this channel is to have at least 50 subscribers, so can you be one of my first 50, please? And I hope to post one video every week, and I want to improve my own evaluation skills for peer-reviewed papers and just beginning on the research track, and I really enjoy it, and I'm always willing and eager to improve. My inspiration for creating this channel is I appreciated how there's a bodybuilder, powerlifter, Jeff Nippard. He uses scientific articles to back suggestions he recommends if you want to bulk up or gain more muscle. I am interested in going into research, as I had said, and I wish I could have learned more about research when I started medical school. So I hope this is a way to kind of give back. And some papers have weak research designs and validity, but yet their findings kind of spread rapidly amongst some people, and that actually could lead to harm. An example that really comes to mind is the not seminal in the sense that it was really strong, but the paper about vaccinations and autism. So, because I'm in my OB/GYN clerkship and pediatric clerkship for now, I think my topics for the next coming weeks will be about kids and pregnant women. Some other disclaimers I want to put is, any suggestions from these papers don't. The final say is go to your doctor. Your doctor has the final say. And don't take this for word. It's just for me to help you kindle your interest in reading scientific papers and learning how to kind of evaluate them, to separate the weeds from the sunflowers, so to speak. So this paper I want to talk about is a Cochrane paper. So before I begin on this paper, I just want to talk about different research designs. So we tend to believe in like a hierarchy. You have like case reports, which are you're talking about one patient that had an unusual case. Then you have a group of people who you observe to have a particular disease, and you try to find out like why by comparing them with people who don't have that disease. So for instance, you have people who have lung cancer, and you have people who don't, and you try to find what's the cause. And in the 1950s-ish, I don't exactly remember when, but you had smoking as like a possible contributor at that time. And then you have interventional studies where you kind of I'm going to give you medicine, and I'm going to give you a coded pill that looks like that medicine, and let's see if it changes any outcomes. And this is like randomized. And lastly, you have like a kind of meta-analysis, systematic analysis. This is, you'll look at all like randomized controlled trials, all observed trials, and you compile that. Like, what did this study find? What did that study find? And based on the compilation of results, you come to a decision or a finding. And that's what Cochrane reviews are. They're really strong papers for doctors and researchers alike. So if you mention a Cochrane review, it's very well respected, and they have a lot of studies that they include and ways to limit bias as well. So this Cochrane review paper is Omega-3 fatty acid addition during pregnancy by Dr. Middleton et al. So why this paper was made? The question that Dr. Middleton and team wanted to answer was, does fish oil help pregnant mothers and babies, and if so, in what ways? And this is helpful because maybe it could reduce preterm birth. And preterm birth is, if your baby is born less than 37 weeks, it's scary because there can be, baby can be really sick, can be sent to the neonatal ICU. Baby can unfortunately die. So this question is really important. And also, Dr. Middleton and team note that many pregnant women do not eat fish or use omega-3 supplements. What did Dr. Middleton and team find? They found 70 randomized controlled trials involving 19,927 women. That's a lot of people to study on. And basically, these studies randomized pregnant women such that they would either get the fish oil or they would not. And they looked at whether the baby was born preterm. They looked at how large was the baby, and they looked at was the baby sent to the neonatal ICU, NICU. Pregnant women who took omega-3 supplements had less preterm births and less very preterm births, which is less than 34 weeks. Also, they found that those women who took the omega-3 supplements, fewer babies had lower birth weight compared to the babies whose mothers did not take the omega-3. The risk of the baby dying or going to the NICU may be lower for those taking omega-3, and but also they had mentioned that mothers who took omega-3 probably had increased pregnancies continuing beyond 42 weeks. So there are a lot of findings here that Dr. Middleton and team made, but I guess when I read this, my question was, how strong are these findings? For instance, having the finding of your baby is less likely to be born preterm versus you're also likely to have a pregnancy lasting beyond 42 weeks. Like, if I were to compare what has more effect, how do I know? So I'd like to introduce you to a lot of papers of systematic reviews, like this one. Used the GRADE, which is an acronym for Grading of Recommendations, Assessment, Development, and Evaluations. And this is another paper just describing what GRADE is. It's written by Dr. Semenuk and Dr. Guyat. But basically, you take into account each scientific paper in the that you read, and you see if it's biased. You see if randomization was done, and you take all these measures and you make an evaluation. There's 4 categories for grade: high, which we can be confident in the finding; moderate, low, and very low. So In terms of Dr. Middleton and team's findings, what were the high ones? So the high ones were preterm births, less than 37 weeks, early preterm birth, less than 34 weeks, and low body weight. So basically, those are the ones I would feel most confident in, meaning the woman who took the omega-3s during pregnancy, they were less likely to have preterm birth or early preterm birth, and less likely to have a baby that was low body weight. And in terms of risk, evaluating risk, for example, like if I'm pregnant and if I have a baby and I take the omega-3, how likely is it that I'm not going to have a preterm birth? So that's what Dr. Middleton does with the assumed risk and the corresponding risk. So basically, like out of 1,000 women who don't take omega-3 supplements and who are pregnant, 134 of them will have preterm births. But out of 1,000 pregnant women who do take omega-3 supplements, 119 of them will have decreased preterm birth. So that's my just quick kind of explanation of this paper. I do think it's very useful for expectant mothers and fathers alike. And I hope this helped you for at least a little bit, and I look forward to sharing another paper next time.